We all would have read, would have heard, and even used this one term named average in our day-to-day life, a lot of time. Well, if you have used it, but you don't know that why you use this term, then this video tutorial is about that. We'll discuss what's average and why do we use it. So before moving, entering into the discussion, I want to tell you that in order to calculate average, we actually have three tools. The first one is mean, the second one is median, and the third one is mode. Mean, median, and mode, these are the three tools using which we calculate average. Well, it depends upon the situation whether you will use only one of these, two of these, or all of these. It completely and entirely depends upon the situation. Okay, point number two, I'm not going to discuss about mean, median, and mode in this video tutorial. We will, save this discussion for our, next couple of tutorials. In this video, we'll focus only on that. What do we mean by average? Okay. Read this first statement. What does it say? It says the average age of the students in a class is 12 years. Suppose we have a class of strength 30 students. The strength of a class is 30 students or is 30. Okay. This set contains a data, and this data tells us the values of ages of all the students in this particular class of strength 30. So the first student's age is 10 years, second student's age is 11 years, the third student's age is 12 years, and so on. Okay, you can clearly see that some of them are of 10 years, some of them are of 11 years, some of them are of 12 years, and so on. But still, we say that the average age of the students in a class is 12 years. This average is the main thing. This average tells us that if we take all these values, so these values are like 10 years, then 11 years, then 11 years, some are 10 years, some maybe of 9 years, then 12 years, again 12 years, 12 years, then 10 years, then 11 years, and so on. Let's say that if we represent these values, that is, these values are the ages of students, then they all will point towards a value, or these values will represent one thing, and if this value can be found, then that will be actually average value, and this average value is actually representative value or central tendency. In this case, despite the fact that all the students are of not the same age, some are of 10 years, some are of 11 years, then 12 years, and so on. But if we want to, represent a value, and that in this case tells you of 12 years, so it will give you an idea that, okay, in this particular class, the age of all the students actually revolve around 12 years. That is, most of the students are roughly of age 12 years. That is what is representative value. Representative value, in this case, that is average, is 12 years, represents, this set or the data or the values that is contained in this set. This value is actually representing this particular set of data, and that's what actually central tendency is. The central tendency, okay, you can quickly think that, okay, if the average age is 12 years, that is a central tendency in this set of data is 12 years. It means that most of the students are of, somewhere around 12 years of age. In this case, the average attendance of a class for the month of December is 90%. Again, assume that the total strength of the class is 30. We are talking for the month of December, starting from 1st of December till 31st December. We have represented the values of percent attendance for each day. Let's say this is for the 1st December, this is for 2nd December, this is for 3rd December, and so on. This fund value, that is 100%, is telling you, is telling you attendance on 31st of December. Okay, now if I say that the average attendance of a class for the month of December is 90%, then it means that the values contained in this set of data, that is all the attendance for the month of December, they all will be pointing towards an average value, and that value is actually the average value that will represent this set of data, and therefore it will be representative value or central tendency. So when we calculate the average, I'm not going to explain you how we do this, it's for the next videos. But if we calculate the average, it means that we have calculated actually representative value or the central tendency. And what does it tell? It tells us that we have got one value that will represent this set of data. In this case, this set of data contains the values of attendance for each day of the month December. Okay, in this case, if it is 90%, does that mean that on each and every single day for the month of December, the attendance was 90%? No. You can clearly see that. For some days it was 96, for some days it was 95, for some days it was 98, then 100, then 100, then 99, then 94, and so on. So if we calculate the average and it points towards this one value, that is 90 in this case, then it will give you a rough idea that, okay, for the month of December, for this particular class of strength 30, the average attendance, the attendance of this class would have been around 90%. Take this one. In this case, you have the average temperature at this time of the year is about 40 degrees Celsius. The period is 20th of April till 30th of April. And let's say that you have recorded data for this period starting from 2010 and up to year 2019. So this is for the year 2010. This is for the 2011. This is for 12, and finally this one, and so on. And this one will be for 019. That is 2019. So we started from 2010, we reached to 2019. For this particular period, we have recorded the temperature for this period starting from 2010 to 2019, and this has been represented in a form of a set. So this set contains a data, and this data is values of temperature for this particular period starting from 2010 to 2019. Now, Does this mean that for each and every year during this period the temperature was 40 degrees Celsius? No, you can clearly see that. In 2010, during this period, the temperature was 39 degrees Celsius. In 2011, it was 40. In 12, it was 41. Then 40, then 40, then 40, then 42, then 40, then 41, then 39. It means that for this period, starting from 2010 to 2019, it's not like that for each and every year the temperature was 40 degrees Celsius. But if it tells that the average temperature, it means that if we try to calculate the average for this given data, that from these values, then they all will point towards a single value that will be the average value for this data or for these values, and that will be called representative value. Why representative value? Because that particular value will represent this set of data, that is for these values, or central tendency. So in this case, if it is 40 degrees Celsius, then you can think, okay, if the average temperature for this period, that is from 20th of April, between 20th of April and 30th of April, starting from 2010 to 2019, if the average temperature is 40 degrees Celsius, then it will give you a rough idea that the temperature during this period from 2010 to 2019 will be around 40 degrees Celsius. That is what it's a representative value. This 40 degrees Celsius is a representative value for this set. Or even we can say that it is a central calculation of central tendency, that if this data was given to you and if you are told that the average for this data is 40 degrees Celsius, then you can think that okay, the temperature would be somewhere around 40 degrees Celsius. That's the average or the representative value or the central tendency. In order to calculate average, we can use either arithmetic mean or median or mode, and it all depends upon the situation given to us or the question being asked. Not in every question you can apply arithmetic mean or median or mode. It all depends upon the situation. This video tutorial is about arithmetic mean. We are going to discuss about arithmetic mean. Now, arithmetic mean sometimes is referred to as simply as mean. Okay, it is called simply as mean. So if someone asks you that you have to calculate mean, then that person actually means that you have to calculate arithmetic mean. Now, suppose we have a data set. Let's say we have 2, then 4, 8, 12, and 16. Now, if you have this data set and if it is asked that you have to calculate arithmetic mean of this data set, then what you have to do is first add these values. So 2 plus 4 plus 8 plus 12 plus 16. After adding these values, you have to divide this by the number of values. So how many values do you have? You have 1, 2, 3, 4 and 5. Therefore divide this addition by 5. What you will get? 4 plus 2 is 6 plus 8 is 14 plus 12 is 26 plus 16 is 42. So 42 divided by 5. Now you can write this, simplify it and write in the form of a decimal number, or you can represent this particular number, that is 42 or 5, as a mixed number, right? So if you have to write this number in the form of a mixed number, then you will write it as 8, 2 or 5. So this value or the decimal number that you will calculate, in this case if you want to write this in the form of a decimal number, then that will be 5840 and 0.4. 5422, yes, okay. So 8.4 will be the decimal representation for this one. So either this or this will be the arithmetic mean for this data set. So what's the way? First add all the values given and divide that addition by the number of values present in the data set. Let's understand this further using some real life examples. Suppose we have three containers, container A, container B, and container C. Container A contains 2 liters of milk, container B contains 9 liters of milk, and container C contains 1 liter of milk. If it is asked to you that how will you divide the milk in these three containers in a way that you have equal milk in each of these containers. So you'll say that, hey, that's very simple. You know what? You have 2 liter milk, then you have 9 liter milk, and then you have 1 liter milk. If I have to represent this, the amount of milk in these three containers in the form of a data set, then that will be 2, 9, and 1. Now, if I calculate the arithmetic mean, why? Because what I have to do simply is add all the milk, right, present in these different containers and divide them by 3. That will give me the value. And that's actually what? That's arithmetic mean. If you add all the milk present in these three containers, that is 2 plus 9 plus 1, then if you divide them by 3, then that's what? Actually arithmetic mean only. So you are calculating nothing else but arithmetic mean. So 2 plus 9 plus 1 divided by 3, this will give you 12 divided by 3, and this will give you 4, that is 4 liter. That is, each container should contain 4 liter of milk. That's what we have represented here. Let's take one more example. Suppose on Monday, on Tuesday, on Wednesday, on Thursday, and on Friday you study. These are respective hours for each of these days, and you rest on Saturday and Sunday. So on Monday you study for 8 hours, then for 4 hours, then for 5 hours, then for 6 hours, then for 7 hours. Okay. If I represent this in the form of a data set, that is 8, 4, 5, 6, 7. These values in this data set tell you about the studying hours on Monday, Tuesday, Wednesday, Thursday, and Friday respectively. For a moment, forget this question. Just forget this. Okay. Now, if you look at these values and the data that is given here, so if someone asks you that, hey, this is actually, a data set for studying hours for your studying hours for Monday, Tuesday, Wednesday, Thursday, Friday. So what do you mean by that? Then you will tell her, hey, that you know what? Actually, that means that if I calculate the arithmetic mean, then I can tell you my average hours, that how many hours I study daily. So if you want to calculate the arithmetic mean, and that's what it is asked here, how many hours do you study daily on an average, right? This is the importance of calculating average. That's why we also say that average is also known as representative value. Because without average, without representative value, a given data set is nothing. That's why I said that for a moment, forget this question, okay? Forget that you have to calculate arithmetic mean. If this is the data set given to you, then what you will, interpret from this one, or any person, if you will tell some person that this data set tells that this data set tells about the studying hours for Monday, Tuesday, Wednesday, Thursday, and Friday. So how you will use this data set? So you will represent a value that will represent your data set and will explain something to the user. Okay. So in this case, we have arithmetic mean. And if we calculate this, then that will be 8 plus 4 plus 5 plus 6 plus 7 divided by 1, 2, 3, 4, and 5 values. This will give you 8 plus 4 is 12 plus 5 is 17 plus 6 is 23 plus 7 is 30 divided by 5, and that is 6. That is 6 hours. 6 hours is your arithmetic mean, that is, it is average. That gives average studying hours. So what does that mean? That means that if your average studying hours is 6 hours, that means that on an average daily you study for 6 hours. Does that mean that you on each and every day you study for 6 hours? No, because you can see here on Monday you are studying for 8 hours, then for 4 hours, then for 5 hours, then for Thursday it's 6 hours, then on Friday it's 7 hours. Not every day you are studying for 6 hours, but if I calculate an average using arithmetic mean, then that average will tell a person or anyone or even you that on an average you study for 6 hours daily. What about this one? Again, for a moment, forget this one. So 5 match series, in the first match you score 100, then in the second match you score 50, then 60, then 30, then 60. So if this is represented by a data set as 100, 50, 60, 30, and then again 60. So what will this data set tell anyone, even to you also? What will this data set tell? You will say that 100, 50, 60, 30, and 60 in this data set are the values of the scores that have been scored in each of the matches, or in the 5 match series. Okay, so if you have to represent a value, if you have to calculate a value that will represent this data set, that will be a representative value, because that can explain something to any of the user or even to you, and that will be actually what average. And in this case we can use arithmetic mean. So if I calculate arithmetic mean of this data set, so this is 100 plus 50 plus 60 plus 30 and then again 60, and you divide it by 5. 100 plus 50 is 150, plus 60 is 210, plus 30 is 240, plus 60 is 300. So 300 divided by 5, this will be 60, that is 60 runs. These all are actually runs, 5 match series, okay? These all are runs. It means that on an average, you or any batsman for whom these values have been given, that person actually scores 60 runs per match. That's an average. It's an average value. It means that that batsman calculates on an average 60 runs, has scored 60 runs in each of these matches. Does that mean that in every match that batsman has scored 60 runs? No. You can see here, in the first match it was 100, then in the next it was 50, then in the next it was 60, then 30, and then 60. So not in every match the batsman has scored 60 runs, but if we calculate the arithmetic mean, then that will tell us, this average value will tell us that on an average 60 runs per match. So this is, these were some of some real world examples, and I tried to explain you that what's the importance of arithmetic mean and what do we mean by that.